Okay, this is section 2.4. We're talking about trends, interpolation, and extrapolation. First, starts off, have you ever heard of people say that the price of a comic book was only 10 cents when you were young? Or that their allowance was $2 a week? Over the years, the prices of most items have increased. You can analyze these trends and use them to make predictions. So, that's an example of what's called inflation. We have an investigate here that involves this graphing calculator that we don't have. So we're actually going to look at the first example. We're going to start off with the first example. So before we do that, we want to look at two types of graphs. Okay, these are both scatter plots, as you guys should be familiar with. The graphs can help you recognize trends in a set of data. If you find a trend, you can use it to predict values of the variables. So the first one is an upward trend. Remember, when we're looking at graphs, we always want to read the graph from left to right. So we can see here all of these data points, which again is just a coordinate point, x and y value, are trending upwards. In this particular graph, they're trending downwards. Okay, so this is two types of graphs that we're looking at. There's an upward trend here and a downward trend. The first example asks us to make predictions. It says this table shows the number of paid admissions to movies in Canada for 12 months periods, fiscal years ending on March 31st. So here's our data points. Again, we have one variable that is going to be the independent variable and the other one that's going to be dependent. Okay? As we've discussed in the past, primarily the independent variable is almost always time. Okay, remember, so independent always goes on the x-axis and the dependent is on the y. So another way to think of that is the x value, or these years that we're measuring, they're chosen, and the y values is the data that we're measuring. Okay, that's the way to think of it. Measuring is dependent and chosen is independent. Any questions about that? Yeah, Christian.
What if most sets of data you're given are measured?
Yeah, you have to use your common judgment then to determine which one is depending on the other. Okay, but you're right. You can have situations like that. Temperature being one, and maybe growth of a plant. Okay, which one is dependent on the other? I would say the growth is dependent on the temperature, but you're still measuring the temperature, right? Agreed? Yeah, Tyler.
Like for one of the examples in one of the previous chapters, it said like that the x, the independent one, like the y, for example, is dependent, right? So it's dependent on x. And they had like an example of where like a bird had a wingspan of this and a body mass of this. So which one would it be? Because those are both measures.
Yeah, those ones in particular are difficult. It really depends on what type of experiment that you're conducting and what you're interested in to determine which one is dependent. Sometimes you're going to have something like that, let's say hand span versus height. And you can't say one is necessarily dependent on the other. There's a correlation there. Right? A correlation where they're both kind of dependent on each other. So it's tricky. In that case, you could actually graph it either way. So you could put the variable on either the x or the y-axis and then just graph it. And your graph would still give you the data of the comparison. It just would look different than if somebody chose to put them on the opposite axes, right? So there are cases when it's not quite clear which one's dependent and which one's independent. But the important thing is, in clear cases, you guys all know the difference between independent and dependent variables, right? We discussed a bunch of different examples of that. One of them was, say, a hockey tournament. If we were doing number of goals scored versus numbers of games played. So still kind of the same unit, which would be number of. You guys should all realize which one is independent and which one's dependent. Right, Matthew, number of goals scored, number of games played. Which one's dependent, which one's independent?
Games is independent because the games, they're always happening and you can score a different amount of goals in each game.
Yeah, good. So the dependent would be goals scored because it's dependent on how many games you play. The number of games you play is not dependent on the number of goals you score at all, right? Generally speaking, the more games you played, the more goals you're going to score. It's dependent on it. Another way to think of it, again, is that the number of games played, it's chosen. You're choosing the number of games that you play, correct? And the number of goals scored, you're measuring that, right? Each time the puck goes in the net, you're counting, right? Any questions about that? All right, so independent, dependent. If you're not clear, you should kind of go back to some examples and try to get clear or look it up. You can always search on the internet to get another explanation. So the first one says graph the data. So we're just taking these points now, and I would typically make a scatter plot, so single points like this. The book chose to make a bar graph for whatever reason, which is here. Okay, you could have just represented these as points. Okay. B says describe any trends in movie attendance from 94 all the way up to 2004. So we can say that it's an upward trend. Again, that's because it's moving, as we read from left to right, it's moving upwards. They did not survey attendance for the year from April 2001 to 2002, so there's no data. Estimate the movie attendance here during this period. So the movie attendance we know is going to be right around this area. Okay, why do we know that? Because the rest of the data is fairly consistent. Okay, so that's called, when we're guessing a data point within a data set, it's called interpolate or interpolation. Okay, so that's this definition here. When you estimate a value between two measurements in a set of data. Any questions there? Okay, next question asks to find out what the number of admissions would be in 2006. So this would be 2004. 2005 and 2006 is over here. So they're asking us, what would this value be? And I would predict somewhere up there, right? Somewhere in that neighborhood. Maybe that's a bit high. Somewhere here, maybe. Okay? Tyler asked yesterday, is there a mathematical way to do this, to get a prediction here, as opposed to just kind of visually seeing where it would be? And one way you could do it is you could calculate all the averages of the differences between the years. So you take this value here minus this value and you calculate this step, this step. You add them all up, all of these differences, and then you divide by the number of differences or number of value points, okay? That'll give you the average difference between the year, and then you would multiply that value by the number of years you're looking to extrapolate. So in this case, 3 more years. So 3 more steps, right? So you're basically calculating this kind of step up, or this Y value average. Any questions about that? I think in most cases, though, you will be able to just do a visual estimate. The point is that you understand what an extrapolation is. You're taking the existing data, you're going along the same trend, and trying to make an estimate on what the value would be. And there's no exact right answer, okay, for any of these when you're extrapolating or interpolating for that matter. Finally, it asks us about a SARS outbreak. Would you change your prediction based on this additional information? So in 2003, there was a SARS outbreak. So notice there was a big dip in the attendance in 2003. So it's asking us whether we would change our prediction based on that dip. So depending on you, depends if you think that SARS outbreak had a significant impact on admissions, which it looks like it did. You can actually eliminate this year as part of your data point because you don't feel that it's representative of the data. Okay? That's called an outlier, Tyler. Yeah, that's called an outlier. Any other questions with that example? All right, we covered a lot there. Key concepts: a pattern in the graph of a set of data often indicates a trend. We talked about that. You can interpolate values between those in a set of data. And finally, you can extrapolate trends to predict values outside the range of set of data.